All right, just because sometimes a couple of videos isn't enough, we're going to go through and do this last one. Okay, pay attention to this. That is 4. So now I need 4 of something to get out. So think 4, 4th root of 16. And you can either look at your chart or you can, use your brain, whatever. That one comes out to be a 2. Here I have 4 x's. They can come out in groups of 4. That would be one group with 0 leftovers. Here I have 9 y's. Coming out in groups of 4, that would be 2 groups of 4, which would leave me with 1 y under there. But don't forget that the index you have at the end should match the one you had at the beginning. All right. Here, I'm going to go ahead and distribute this 1/3 power. So I'll have 27 to the 1/3, x to the 4/9, and y to the 3/12, because I have to multiply the tops of the fraction. So for example, when I'm multiplying 4/3 times 1/3, I multiply the tops and the bottoms, and that is where this comes from. Now I look to simplify. The cube root of 27 is 3. X to the 4/9 does not reduce, so I leave that. And then y to the 3/12 can reduce to a 1/4 power. And I want my answer to be in fraction powers if my question was in fraction powers. So like this one, starting off as a radical sign, I'll want my answer as a radical sign as well. 162 is not a perfect cube. It's not on your chart in that 3rd column, but 27 goes into it 6 times. And 27 is a perfect cube of 3. But the 6 gets stuck under there. I'm probably going to have to scoot this 3 over. It looks like a lot of people are coming out. Oh, maybe not. So k to the 12. Coming out in groups of 3, you're going to have k to the 4th power. No leftovers. D to the 10. Okay, so coming out in groups of 3, you could have 3 groups of 3, but that would be 9, leaving you with 1 extra lowercase d. All right. Here we have quite a mess. This one, the half power distributes to everybody, keeping in mind that anything to the 0 power is just 1, so that's a goner. Here, the cube is going to distribute. So p will be to the 8 times 3, or 24 power. Q will be to the 4 times 3, or 12 power, and R will be to the 2/3 times 3, so the 3's will cancel, and R will be squared from the first part. In the second part, we'll have 25 to the 1/2. P is going to be to the 4 times 1/2, which will be 2 power. Q is going to be to the 8/10 times 1/2, which would be 8/20 power. We'll worry about reducing next. And then I'm not worried about this part because that disappeared. Okay, so 25 to the 1/4 power. Oh, wait a second. I put a 4 here. Sorry, that was just a mistake. So when I distributed this should have just come here as a 1/2 power. So 25 to the 1/2 power is a 5, which I'm going to put out in front. Here I have 24 p's. Here I have 2 more. So I'm going to have p to the 26 power. Here, these q's kind of need to reduce. So I can reduce this since 4 goes into both. This becomes q to the 2/5 power. But then I have to add the 12 plus 2/5 and add those 2 powers together. So when I do that and I use it as a fraction, I end up with 62/5. So I'm taking my q here to the 12 power, and then I'm adding 12 plus my 2/5, changing it into an improper fraction on my calculator and getting 62/5. And then I have my r squared, which is the only one I've got because the other one disappeared from the 0 power. Messy problem, messy answer. We are winding down finally. So I've got a radical. 54 is not a perfect square, a perfect cube, but 27 is. Multiplied by 2, it becomes 54. So from this, a 3 comes out and a 2 is stuck in. 8 x's. how many groups of 3 would that be? Well, that would be 2 groups of 3, which is 6, leaving me with 2 inside. 12y's, how many groups of 3? 4. No leftovers. I'm done. Check that I used the same index in my answer as was in the question. And the grand finale, finally, going to be distributing that 1/5 power to everybody. 1/5 of 20 is 4. And here I get 4/5 because I'm taking 4 over 1 times 1 over 5. All right, how about in the second round? I'm going to have 4 to the second. X to the 2 times a half will just be the 1 power. And here, this will turn into y to the 2/10 power, which is the equivalent of 1/5. Okay, so this 32 to the 1/5 is a 2. 4 squared is a 16. And so because they are both numbers, I can put them together to make a 32. And I'm multiplying, so they become the 32. X to the 4 here, 1 more x here, x to the 5 in my answer. Y to the 4/5 plus a 1/5, because I'm multiplying them together, I'm going to add their powers. 4/5 plus 1/5 is thankfully 5/5, which is just 1. So that, my friends, is the end of all of these review problems. And hopefully you can kind of get the gist that we're going to do solving, which is going to be a whole lot of kinds. Some with powers, some with fraction powers, some with radical signs. You have to be able to transfer back and forth between the exponential and the radical form. You need to be able to graph the square root, the cube root, identify domain and range, and then you need to be able to simplify these that have the radicals and fraction powers. So there's plenty to do. Take your time practicing, redoing, rewatching, discussing, whatever it is you have to do to practice so that you feel like you're going to be able to ace this, no sweat. Have a great day.